Hello everyone, welcome to my channel Similarity. This is the second part of the matrices series, and in the previous video we have covered the basic theory of the matrices. We have covered these topics in the previous video: what is matrix, application of matrices, order of the matrices, types of matrices, property of identity matrix, transpose of matrix, addition, subtraction and multiplication of matrices. Okay, and in this video we will see some more theory, and we will also discuss some theory which is specific to Houdini. Okay, so let's just jump right into it. Okay, so the first thing that we need is attribute wrangle here. Okay, let me set this to details because we don't want any kind of input. Okay, so the first thing we will learn is how we can create matrix inside Houdini. Okay, to create a matrix you can basically write it like this: matrix, and you can see that we have these three types here: matrix, matrix 2 and matrix 3. Basically matrix is used to create 4 by 4 matrix, and 2 and 3 as you have guessed 2 by 2 matrix and 3 by 3 matrix. Okay, so let's begin with this one, matrix 2. Okay, you can give it any name you want. Let's call it mat2 and then write it like this: set 1 comma 2 comma 3 comma 4. Okay, so this is our 2 by 2 matrix whose name is mat2, and these are the element of the matrices. Okay, also if you want to create this in the form of attribute, you can write it like this: 2 at the rate, and let's call it mat2 as well, and then you can simply assign this value here. Okay, yeah, and you can check it here, and you can see this is our 2 by 2 matrix. Okay, similarly we can also create a 3 by 3 matrix as well. Let me just copy it here, and just instead of mat2 you can rename this to mat3, and also let's call this mat3, and let me increase the number of elements: 5, 6, 7, 8 and 9. Okay, so this is how you can define a 3 by 3 matrix. Also you can create a attribute here: 3 at the rate, let's call it mat3, and you can assign this. So you can see here, this is our matrix 3. Okay, it's a 3 by 3 matrix. Okay, with the element 1 2 3 4 5 6 7 8 and 9. Also if you want to create a 4 by 4 matrix, you can simply write matrix. You don't need to write 4 after that, just write matrix and give it a name. Let's call it mat4, and you can set its value. Let me copy this from here, and we can increase the number of elements here: 10, 11, 12, 13, 14, 15 and 16. Okay, so also if you want you can create a attribute also. Let's give it a name mat4, and you can assign the value here, right? So you can see this is our 4 by 4 matrix. Okay, so this is how you can create a matrix inside Houdini. Also if you want, you can create a attribute of matrix using like this. Okay, also there's one more type of matrix, if you remember, it's called an identity matrix. So you can basically create it like this. Just simply let me create a 3 by 3 identity matrix. You can write here matrix 3, let's call it imat. Okay, and you can write ident. You can use this ident function. Basically this create a identity matrix. Okay, if you want you can check it also. You can write 3 at the rate, let's call it imat. Okay, and you can see here 3 imat, yeah, this here. Okay, so this is our identity matrix where all the diagonal elements are 1 and other elements are 0. Okay, this is we have discussed in the previous video, if you remember. Here, see, this is how an identity matrix looks like. Okay, where all the diagonal elements are 1 and other elements are 0. Okay, now let me go back to Houdini. Okay, so these are some of the ways you can define a matrix inside Houdini. Also, there's one more way that let me show that to you. Let me just copy it here and delete all these. We can also basically create a matrix using vectors. So let's define a vector here. Let's call it vector v1 set 1 comma 2 comma 3. Okay, let me copy it. Let's call this vector 2 v2 and also change the elements if you want. 4 comma 5 comma 6, and let's call this vector v3 and change the elements here 7, 8 and 9. Okay, now we can define a 3 by 3 matrix like we did earlier. Simply we can call it mat 3 here, and we can call it mat, and we can write it like this v1 comma v2 comma v3. Okay, let me check what we are doing wrong here. Invalid declaration for vector. Okay, sorry. Okay, so that's how you can create a matrix also using the vectors, and you can also check if you want. You can create a matrix attribute here. Let's call it 3 at the rate mat. So you can see here we have our 3 by 3 matrix. Okay, and this matrix is created using a set of vectors. Okay, so these are some of the ways you can create a matrix inside Houdini. Now let's see a very basic operation that we can do using matrices. And also we have discussed this in our previous video, if you remember. Basically we are trying to do this here, a scalar multiplied by a matrix. Okay, so we are basically now going to do a scalar multiplication of a matrix. Okay, so let's see how you can do it. Okay, we can also do it here if you want. It will be very easy. So let's create a scalar here. Float. You can call it a scalar. CHF, and let's call it a scalar as well. Okay, and now what you can do here is basically 3. Let me delete it. Delete this one and copy it here. Okay, now we can basically multiply this matrix with this scalar value. Okay, and now you can see right now our matrix is all the elements of the matrix are 0, because as we have discussed in the previous video, when we multiply a scalar value with a matrix, then all the elements of the matrix will be multiplied. Okay, so now the scalar value is 0, that's why all the elements are 0. Now let's set this to 2 here, and you can see now all the elements of the matrix is multiplied by 2. So we have 2, 4, 6, 8, 10, 12, 14, 16 and 18. Okay, so that's how we do a scalar multiplication with the matrix. And now we will see how we can multiply a vector with a matrix, right? So before I begin, you need to remember two rules for the vector multiplication inside Houdini. Rule number one is when you multiply a vector with a matrix, you always get a vector in return. Okay. And rule number two is vector multiplied by matrix is always equals to matrix multiplied by vector. Okay. So these two are same things. Whether you multiply a vector with a matrix or matrix with a vector, you always get the same output, right? So these two are same things in Houdini. So remember these two rules, and now we can begin the theory part, right? So let's say, let me first create a attribute wrangle here. Let me create a matrix here. Let's create a 3 by 3 matrix. Let's call it mat, and let me set its value to 1 comma 2 comma 3 comma 4 5 6 8 and 9. Okay, now let's create a vector here. Let's call it v1 and set its value to 1 comma 2 comma 3. Okay, and let's create a vector and call it well. Okay, or you can call it v out, so that we will remember that this is the output. And now let's multiply it. v1 multiplied by mat, and let me create a variable, sorry, attribute here. v at the rate v out equals v out. Okay, so you can see here, this is the output we get after multiplying the vector with this matrix. And let's see how this actually works. Let me tell you. So basically this is our matrix here that we have created in the Houdini. This is our mat 1 2 3 4 5 6 7 8 and 9, and our vector is v1 vector is like this 1 comma 2 comma 3. So what basically happened, the first thing the Houdini does is convert this vector into a matrix which looks like this, and then it multiplies it by our matrix here 1 2 3 4 5 6 7 8 and 9. And as you remember, this is our 1 cross 3 matrix and this is 3 cross 3. So the number of columns here and the number of rows here are same, so we can do the multiplication, and the multiplication will happen like this, row by column, right, to each of these column. And if you do it here, you can check 1 multiply by 1, then plus 2 multiply by 4 plus 3 multiply by 7. And similarly you can do this for other columns as well if you want to check. Let's check this one here. It will 1 8 and 21, so that will be 30, right? And you can see this is our first element. Similarly you can check other elements also, but that's how multiplication happens internally, right? First vector is converted into a matrix and then it is multiplied by the this matrix here. Okay, so this is how we do a matrix multiplication. Also, let me tell you one thing that I've told you earlier. I've told you that vector multiplied by a matrix is equals to matrix multiplied by vector, right? These two gives the same thing. Let's just check this theory if it is right or not. Okay, so we have multiplied this our vector with a matrix here. Now let's see if I do it like this. Let's call it v out 2, and this time multiply the matrix with a vector. And let me copy it here. and let's call this v out 2 and this also v out 2. And you can see we get the same result in both these cases, right? So our theory is right. Like I told you, in Houdini, a vector multiplied by matrix, or we can say multiplied by vector, is same thing, right? Also, but just remember one thing: people always get confused, because if you actually check it here in actual theory, you can see if you write, say, this is our matrix, right? This is a 3 by 3 matrix. But if we put our vector here, 1 comma 2 comma 3, you can see this is 1 cross 3. So if you see here, this is actually not possible theoretically, right? Because the number of columns here is not same as number of rows here, and as we discussed in our previous video, these two must be same for the multiplication to happen. But theoretically, you can see this is not possible. But in Houdini, we don't have to take care of these things, whether we are multiplying the matrix with a vector or vector with a matrix. Houdini don't complain about these things. Houdini just multiply it. So even if you write a vector with a vector multiplied by matrix or matrix multiplied by vector, Houdini actually follows the logic which is correct. So even if you write something like this here, right? Houdini internally do the multiplication this way, the correct way, right? Where we have number of column equals to the number of rows for the for this matrix here, right? Okay, so this is it for this video, and in our next video we will see some more theory, and also we will see some examples also from our next video. Okay, so this is it, and I hope you find this video interesting, and if you like my video, please do like this video and subscribe my channel, and I find it really motivating when you do that. And thank you for watching my video. Okay, bye.